Bass hit your when the bass hit your face, you be like. When the bass hit your face, you be like. When the bass hit your face, you be like. When the bass hit your face, you be like. When the bass give me something that'll get the people. I got something that'll get the people. Give me something that'll get the people. I got something that'll get the people. Bass hit your when the bass hit your face, you be like. When the bass hit your face, you be like. When the bass hit your face, you be like. When the bass hit your face, you be like. When the bass give me something that'll get the people. I got something that'll get the people. Give me something that'll get the people. I got something that'll get the
I'm dancing till the sun comes up. I don't care what's in my
Hey, welcome everyone to Monday Night CAD. I should probably have like an opening sentence. Okay, so today we are going to make a lure turner. Just to give you an idea of what we're about to make, let me open my Printables account, and I should probably open the chat here. Just give me a second. Where's my chat? Okay. Oh, I should log in. Come on. Yeah, so I already have a lure turner, but I don't like it too much. Sorry for that. And for you guys who don't know what a lure turner is, basically when we're making a fishing lure, like this one for example, and we want to apply an epoxy clear coat on it, we want it to keep rotating all the time. So it's basically a motor and some way to attach the lure. This is one of the things that I don't like about this one. What I do like about it though is that these blue things, they basically are screwable, so we can like model other types of attachments. So this is something I actually like about it. What I don't like about it is, first of all, it's not parametric. So if I want to support other sizes of lures, I want to print like a small turner, a big turner, something like that. And also we can stack multiple turners. We can't with this one, but this is what I want. So if we have one motor that can rotate multiple lures at the same time, that's the idea that we're going for. But yeah, this is the basic design. We have a motor here. It's attached to something. It's gonna rotate the lure, and then somehow we want to stack multiple of these next to each other. Yeah. So I do have a general idea about how it's gonna look like, but let's see. Let's open FreeCAD and see what we can do. Now, of course, this is gonna be parametric. Let me just check the audio levels. I think they're a bit high. This should be fine. Okay. So since again we're doing something parametric, we're gonna start with this spreadsheet. And let me open this just to see what we're doing. So the most basic parameters that we can figure out like immediately are we can do the width, the height, and the length. So let's do those immediately. Let's rename this to general. So we will have the width, height, and length. Just put on some random numbers for now. Length, let's do like 200. And what I'm thinking, but I'm not sure about it yet, is what if we make this bottom piece as a single piece, and then this one, at the moment it's like an L shape, but we can make it a T. So this will extend and go up, and then it will slide on the base. So it's not restricted. It's not restricted here at the end. It can slide on top of it, go back and forth, and then we can attach more of these base plates together so it can slide like more. I think that's what I'm gonna do. And then we can basically print multiple of these, like 3 or 4 or 5, and then attach them together. That way you can have multiple lures of multiple sizes running or spinning at the same time. So what we need is, I guess let's do this. Let's call this the base plate. Or no, wait. Let's keep it as general. So here we call this the base plate length, because the base plate should also respect the width and the thickness of each piece, basically. So we have thickness, we have height, we have the width of the base plate for a single base plate, but they could be multiple. We need to figure out a way to join them. We'll see about that. What else? Width, height, I think for now these should be enough to get us started. So let's see, thickness 5, for example. And then we're gonna actually, this time we're gonna do the minimum and maximum values. So we're gonna add input validation. And I forgot to do something. These are all inputs. So let's copy the input keyword, height input and width input. I love how fast FreeCAD is when it's still a new project and then you start adding stuff and it's no longer that fast. If you don't do it right, of course. If you're doing it like in a stream on a hurry. Okay, wait, desktop, FreeCAD. Do we have a lure turner here? Huh. Ooh, that's an old one that I started, but I never actually finished it. Let's say V2. It's just an empty thing with a couple of spreadsheets. Okay, lure turner V2. Width, height, base plate length, and this thickness. So let's do them here. Maybe somewhere here at the end. So to not modify. Whoops. Okay. So this is gonna be equal to let's give it a minimum value. So max. But first, before we give it a minimum value, what will this be? Oh wait, this is the width. Okay, that's fine. I'm talking about the length. We'll get to the length. Width is gonna be equal to max. So the minimum value will be the width input. The maximum value between the width input and let's say 50 for now. We can adjust these later. Height. The minimum value for height. So height, I don't know if it's gonna be measured from the bottom here or I wanna measure it from I think I'm gonna go from the bottom because let's say I have a printer that has a maximum height of 250 for example, and I wanna set that. I can do it from here, right? So let's say that height is the entire height from the beginning to the top. So we need to take into consideration the thickness, right? So if the thickness is 5, then the height can't possibly be 5 or 4. So let's say it has to be 10, for example. So the minimum value for height is going to be the thickness, but not the thickness input, the thickness. So let's define the thickness first. So thickness is here, and the value for thickness, let's give it a value of 3, or we can do 2. Just so if someone added here 0 or minus or something, it doesn't break anything. So thickness is 5. We can call this one now thickness. And now we can go to the height and do the max of thickness. Sorry, height input. And let's say thickness, and then we want to add. Okay, so we will definitely update this later because there are also other things that might affect the height. For example, this motor. I mean, if the thickness is like just a couple of centimeters, then we can't fit a motor in here. So the motor will definitely affect the minimum height. So let's add a to-do somewhere here. Add motor to min. For now, let's just go with this, and the alias is going to be height, and the alias for this is the width. Also, we need the motor for the we need the motor diameter to calculate the minimum width. So we'll add it later. Okay, what else? Base plate length. I don't think we need any extra validation for this other than probably later when we have these values right here, we can add them to the minimum length. So for now, let's choose a random min. Let's see here, update later. This is gonna be maximum value between base plate input length, and let's give it a minimum value of 50 for now. We'll change it later. So now if I go here and say like, whoops, I want these to be -5. Oh, I can't do that. Like -5, -5, -5. You can see that they have minimum values. This is going to be our base plate length. Okay. And sure, let's actual values here. 200, let's go for, or here let's do 150, and then here 200, and here 5. Save. Okay. So let's start with this one, and we want it. Okay, where do we want it? In the plane. We can do it on the left side. So part design, create a body, create a sketch on the left. Okay. And let's create a rectangle going up. Whoops. Okay, so I want it to be centered in the middle, so I'm gonna take this point, and this line, which is the z-axis, and make them symmetric. So now it's completely centered. And this is gonna be a very basic sketch. So we're gonna get the general dot width from here, and the general dot height. Okay, super basic sketch. We could have done it also with a additive primitive. Same thing. Okay, let's see. So we wanted to go this way. Yeah, it's already in the correct orientation, and the value for this is gonna be the general dot thickness. Oh, by the way, I forgot to mention something. So in the project ideas, someone suggested that we do wall mounts for spinning reel and baitcaster reels, and we will do that. I told you that if you have any ideas, put them in the project idea and we will probably do them. But the thing is, I need this lure turner as soon as possible. That's why we're gonna do it today. Thickness is not that good. Let's do 10. 10 should be better. Okay. So that's gonna be this part right here. And we will figure out how to connect them to the base plate also in a bit. Thinking about it now. It might be a bit tricky. No, actually it's doable. It is completely doable because I want to model these as separate anyways. So they're gonna be separate bodies. So for example, we're gonna call this the left let's call it the left piece, or the motor holder. So this is where we're gonna do the opening for the motor, but let's leave it aside now. For now, we're gonna create another body, and I wanna move this body. So let's show the origin. At the moment it's here. I wanna move it somewhere here, so we can wait, what's wrong? Oh, I had the origin selected, not the body, that's why. So in the data, placement, position, and we need to go along the x-axis. So here, let's go by general dot thickness, and let's just add 2 mils. Don't need a spreadsheet for that. So it's gonna start here. And now we can create a sketch on this plane. And for this, also we're gonna do a basic sketch. Again, same thing. Select this, and the center line, make them symmetric. This is going to be our, not spreadsheet. We don't want to use spreadsheet. General dot thickness, and the horizontal is going to be general dot width. Make sure you don't use the inputs. Okay. And now we need to pad this. So general dot is gonna be our base plate length. Okay, so super basic stuff. Now we need to model this plate right here. But before we do that, because I want it to have a specific shape. Or you know what? What are we gonna call it anyways? Wait, let's rename this to base plate. And let's make a new body. So what are we gonna call this? Let's call it the moving what do you call it? Let's call it the moving part for now. And we're probably gonna need a spreadsheet for this, so create a new spreadsheet. Okay, so first I want to think about how this is going to be moving left and right. Because what I used to have was something like this. Okay, don't follow along. Let me just hide this and go to the base plate, toggle. I'm gonna just do something and then delete it. What I used to have is something like this. Basically, then if we take these 2 points, make them symmetric, and then these 2 points, Also make them symmetric. Yeah, probably with a fillet here or something. And then pocket this all the way. I could have typed it down, but basically, yeah, this is what I used to have here. But now I'm thinking about it. And if this is the base plate and I want the thing to slide on it, actually it could work. Yeah, it can work. We can do that. I don't think there's a need to invent something new since this is already working. Okay, back to this. The only thing would be how to attach this to this, which also can be resolved at the end. But for now, the moving part, we need a new plate here or a new spreadsheet for the base plate. So let's call this base plate params. Okay, so I think the thickness of the base plate might be different. But let's see where we will go. So we're gonna call it a rail, and then we need to define the rail depth. Let's say rail angle. So what else do we need? We need how much to cut and the angle to cut at, something like this. This will help us with the 3D printing, because 3D printing cannot print like very steep overhangs. So if we do something here like 45 would be ideal. Depth, we can go for something like 4 or 5, but then we need to change. We need a separate thickness here. And what else do we need? There's something missing. We need to know how far. Let's call this rail edge thickness. So this is how far away from the edge do we need to cut. And we can do something like 4. And I'm thinking if we derive this from the thickness that we have in the general here, or do we leave this for the standing platforms? We can call this moving platform. Rail depth. Okay. We'll get to it. Wait, rail angle. Not thickness, it's an input. So all of these are inputs. Thickness. So rail depth, what will it be? It's gonna be a maximum between 5 and let's do a minimum value of 2. Not 5, of course, it's gonna be rail depth. Come on. Oh, rail depth input. My bad.
Why do they talk like gangsters? Why they don't move like gangsters? Why do they walk like gangsters?
So this is gonna be a maximum of
Why do they act like gangsters?
rail depth, rail angle input, and what's the minimum value for the input? Let's do
Why they don't move like gangsters?
let's do 20, which is super steep for a 3D printer. And the thickness, let's do a maximum value of the minimum value, sorry, of 2 mils. Or you know what, let's do a 1 if someone wants to go so super extreme. Oh, come on. Okay. Okay, regarding the thickness, I think we're gonna define a separate thickness for this one. So let's do that here. Let's do it as 6, for example. And this is gonna be the thickness input. And what we need to do here is we need to be careful because we're cutting 5 mil, for example, and we have a thickness of 1. So this is gonna leave us with, or a thickness of 6. This is gonna leave us with only 1 mil of material left, which is gonna be not good. So we need to set a minimum value for this as the thickness input, what we inputted here, and then we're gonna take the rail depth and let's add 2 mil to that to make sure that we always have 2 millimeter of material. So you see we entered 6, but it refused to be 6, it has to be 7. So we can add 8, for example, here, it's fine. This is gonna be our thickness. So let's modify this. This is going to be not our general, but the base plate dot thickness. Whoops, no, not that. It's the, yeah, the sketch. This is the thickness.
Well, there's no problem. If you had a gun,
General, yeah. Can we do it here? Yeah. So for now, let's set it to 10, similar to the other ones. But we can change it because now if I go here and set this to 9, for example, it's gonna be 11. Okay. Let's hide the first object and let's create a sketch. So we want to draw. Oh, come on, what's going on? Oh, we're in the sketcher. My bad. Okay, yeah, now it's working. We want to draw here. And we need to start drawing that thing. So basically what I drew before when I was showing you what I wanted to achieve, it's the same now. These two are symmetric and these two are symmetric. Okay. So this is going to be our angle between these two. Let's do that. The angle here is going to be the base plate dot rail angle. Okay. and we need to put this one right here, and we already know the thickness, so between the origin and this, the vertical distance is going to be the thickness. Okay, and then we have the depth. So the depth is basically the distance between this point and this point. Rail depth. Okay, what else do we need? We need the, what did we call this? Rail edge thickness. So we need to know, or we need to move this away from the edge by a specific thickness. And we can do that because we know the full width. So we get this from the general spreadsheet. We know the width, but from the center, so this is divided by 2, and then we remove from it the rail edge thickness. Okay, cool. How much did we set this? Rail edge thickness to 4 mil. That sounds about right. So now we can pocket it. I guess we need to reverse it, and we can go through all, so we don't have to define anything. Okay, now you see here the distance between this and this, we can measure it actually. It's 2 millimeters, and that's because the thickness is set to 10 or 11, and the rail depth is 9. So if I set this to 4, then we need to recalculate this, or sorry, close. I think recalculate, yeah, it's 6 millimeters now. And this is at 45-degree angle, which is good for 3D printing. So we're good. And we have enough material here to have a strong part. We can control it here. If we want an even stronger part, we can have it at 5 or more. So 5, okay, 5, that means divided by 2, that's 2.5 divided by, let's see how many walls we have, or 5 divided by 0.45, which is used, we have about 11 walls. Oh, that's super strong. Okay. So regarding how to connect this to that, it's a bit tricky, but we'll figure it out. I mean, we can technically insert this here. Okay, wait. So in the motor holder, let's make it active. We can technically, because this is going to be printed on this side, so we can have stuff coming out of this side. So we can, at the moment, where is your origin? It's right here. So I want a plane here. Let's create a datum plane, attach it to this plane, and go by thickness. So general dot thickness. Okay, so now we have a plane here on this face. Let's create a sketch. Let me show the date again. Okay, so now is a good time to have some tolerance defined. So let's do that. I'm gonna do 0.1 is fine, we'll change it later. This is our input. And then here we need to validate the input. So a minimum value is, let's say 0.02. So it's not 0. And let's call this our tolerance. Okay, so now we basically want to fill this. So in our motor holder, we're already in the sketch. Oh, okay, we're already in the sketch. It's good. Good. Let's redraw it. Making them symmetric. Okay, what else did we have? We had here 45-degree angle. Okay. How are we gonna do this? We can start with this bottom one. That's the easiest one, right? We can go the vertical distance from here to this point is the base plate dot thickness. What? Oh, base plate. Oh, come on. Params dot thickness. And then we need to, so now we're at the top line right here. We need to remove from it the base plate params dot what was it? Depth, rail depth. Now we're exactly on the line and we want to add to it. So we want to go up by general dot tolerance. So we should be 0.1 mils above this. Now here's the tricky part. How do we be exactly 0.1 mil away from this? Because we can't say that the distance between this point and this point is 0.1. That's not how it works. It's gonna be more. The distance between this line and this line is 0.1, but not the points. Now this is a 45-degree angle. We can probably do some math and figure it out, but I'm sure there's an easier way. There's always an easier way. What if we draw this line and then just dimension the distance between two lines? We have it here, like fix a length of a line or the distance between a line and a vertex or between two circles. Yeah, we can probably do it. Just give me a second. So if we draw a line here, something like that, this is the line that we want to be 0.1 mil. So this line and this line are perpendicular. Okay, let's oh, now it's gone, never mind. Oh, come on. Yeah, so you, first of all, you're a construction geometry and your distance is the base plate param dot don't know. No, we defined it in general. dot tolerance. Yeah. Yeah, you see, this one is 0.1, but if we connect this point to this point, it's not going to be 0.1 for sure. So let's model this line. This line right here. So we need to model this line. We know that, or no, never mind. Yeah. Let's put this one here. So we know the distance here. I guess we're just gonna do it from scratch. So that's gonna be the general dot width minus the base pattern params dot rail edge thickness. Oh wait, no, my bad. It's the width divided by 2 because we're going from the center. Yeah, now we're right here. We need the vertical distance. So the vertical distance between this and this is going to be the thickness minus the rail depth. Just want to make sure that these are not repeating. Are they repeating? No. Okay. So this is fixed in place now, and if we go back here and show it, it's right on the line. Let's move this away just for a bit. Now we need to make this line. I think we don't have to though, because I can just take this and make them not 45. The base pattern params dot angle. I get this from the angle, right? Oh no. Good thing I found it now. Okay, and then I can just give this a random distance. Let's say, yeah, 10. It doesn't matter. Right on the money. So this is actually a construction line. So I'm gonna take this, mark it as a construction line. This is very important. And now all I want to do is just put this line on that line, or this point on that line. And now we are exactly 0.1 away from this line and that line. So we have the tolerance. Okay, what else? I think the only thing that's not constrained at the moment is this. And we want it to be, do we want it to be exactly here, or I think we can go down by 0.1 also. So let's do that. We can always change this later when we print it. Whoops, what did I do? Line 0.2 points. And the distance here is gonna be base plate params dot thickness. Okay, now we can pad this into the body. And if we look at it from this side, you can see what's going on. So this is how we're gonna like assemble it. Now how much does it go in? We need to add this here somewhere. So we need a spreadsheet which we need to create. let's call this, what do we call it? The motor holder. Let's use this one. Motor holder params. Yeah. Motor holder params. Let's say the rail. What are we gonna call this? Rail length? I don't know. Let's say it's 25. This is going to be an input. And this is gonna be equal to max rail input. And let's give it a minimum value of 15. And one thing I need to note now is, so I don't forget later, if I go back to the general, so update later here, add rail length. We need to add the rail length to the minimum value of the base plate length, which is, so we have this length right here and we have this one. So we need to make sure that this is bigger than this one. That is important. Motor holder params, okay. Oops, let's save this one. And this is gonna be our rail length. So going back here, this pad is going to be our motor holder params dot rail length. Now, how are we gonna make sure that this will stay in place? So we're gonna insert it all the way, but how do we make sure it doesn't move? And to do that, first give me a second, let's modify something. Let's go to our base plate, and here I gave it a thickness and I added 2 mils. So I'm gonna replace this with the tolerance. Okay, so that's how it's gonna be. And then I'm thinking, what if we had holes here, like a hole in here and a hole in here, and we insert some sort of a pin to pin it in place? Or we can like insert it from the bottom, I don't know. Can even do it from the side or from here. Maybe we do these at the end. Yeah, let's do them at the end. Now it's time to design the moving part. So toggle active body and show me the origin. I want to move this, so I want this to be here at the end. Yeah, somewhere here. So this is gonna be in the Y, sorry, in the X. Let's see, yeah, in the X. We're gonna move it by general dot thickness plus base plate params dot what? Plus, where did I put the tolerance? Was it in the general? What happened? Okay, this is trippy. It's in general. Okay, I tried that. Why did general dot thickness plus general dot tolerance? Okay, now it's working for some reason. General dot base plate length. Let's see. I think at the moment, yeah, we're exactly on this line. And let's yeah, let's leave it here. I think that's fine. We don't need tolerance here in the x-axis because this could be anywhere. It could be here in the middle. It's gonna be like a moving platform. We can move it around, and we can place 2 or 3 of them on the same base plate. So let's hide this and create a sketch right here. Let's see, how are we gonna do this? Because we can do this in multiple ways. We can start from here, draw draw a square and pad it, and then later add this section. Or we can make a big section that is as wide. I think this is what we're gonna do. And then cut away this part later. So we can do something like this, where we have symmetry, of course. And we want to make sure that it covers this slot and this slot. Now in this way, we already know the width, so it's gonna be the full width. So let's just do that. Let's do it on top. The width here is gonna be, whoops, sorry. We need to go into formula editor, and it's gonna be the general dot width. And then for the height, before we define the height, let's just put it down here. So I'm gonna take this point and attach it to this line, and now we can use the height. Okay. Which direction are we? Okay, this is the direction. Click OK. And let's... okay. Now we need to cut the axis. So we need to draw a sketch here and cut the axis. So let's do something. Let's see if we can reuse that sketch that we made here. Where was it? No, not in the base plate, in the motor holder. This sketch. I don't know if it's showing. Let's hide the base plate. Yeah. So this sketch, it's smaller than... It's smaller than the base plate. Is this what we want? Because we want to cut. No. No, we need that sketch for something else. Because we need these for this one also. So let's get it anyways. Or no, leave it, because we need to cut. So first cut the excess, then add the rails, because if we add the rails now and then cut the excess, we might cut stuff from the rails. So the rails will be added at the end. Unfortunately, I think we had to redo some work. So show me the origin again. Okay, that's fine. Let's create a sketch on the XZ plane. And what we need to cut here is basically this. Oh wait, we can cut half and then mirror it. So I don't have to do the entire thing. This is going to be on this line. When you use Blender and FreeCAD, things get mixed up in terms of shortcuts and navigation. Okay, we know this angle. Let's put it first. It's the easiest. This is the rail param angle. And now we can go from here, complete this up to here, and then from here to here. So everything inside this box we need to cut, but first we need to start adding constraints. So let's see. Now we can place this at this point, but I'm just gonna do like 0.1 here. Just make sure that we're cutting everything. For this point, I'm gonna go from the origin to here. It is going to be the base plate params dot height. No. Thickness, sorry. Minus the base plate params dot the rail, not the rail edge thickness. No, it's the depth of the cut. So now we're exactly at this line, but we want to add the tolerance. Yeah, now we're 0.1, exactly what we did to the other sketch. Oh no, now we need to redo this sketch. Okay, let's do this point. So basically this right here. Did I do this as 0.1? Let's make it as tolerance, so we know all the time what the value is. And now, so the distance between this point and this point, so remember we're down by tolerance, so we want to go up by tolerance, then we can want to go up by the thickness and then another tolerance. So it's going to be the thickness of the base plate plus the tolerance we get it from the general spreadsheet and multiply by 2. Now we're here. Okay, this distance is going to be our width, which is in general, divided by 2, because remember we're starting from the center. And then let's add some tolerance just in case. We don't have to, but why not? Because we're cutting from it. Okay, now this is the only thing that's not defined, which is the tricky part. Everything here is defined. Yeah, that's the only point, this one. So we're gonna do the same trick that we did. We need to define a line. We need to basically redraw this line. We can get this here. Put this point on this line, and then this line and this line, they are 45 degrees, which is the base plate param dot angle. We could have made them parallel. I don't know why I did that, but anyways. Now I want this to be exactly here at this point. Now you're wondering, why don't you use, like, for example, in Fusion, I can come here and say, hey, give me that line, and click on it, and then I have a reference to that line. You can do that, But in the current version of FreeCAD, there's an issue or a bug which have been in FreeCAD since forever, which is called, what was it called? Topological naming issue. And that means that if you reference a line or a face or something and then you go and change some parameters, it might break. Because each edge or each face or each vertex, they have a number, like an ID. But that ID might change in the current version of Blender, which will break everything. That's why I try to I do this approach, which is redefine all the sketches. This makes sure that nothing will break my model. I heard that they are working on a fix, and I heard that this fix was merged into the source code, but it was not released yet in a stable version. Okay, so what do we have here? We have the general.width divided by 2 minus the base pattern params dot rail edge thickness. This should be it. Yes, and now we need the vertical distance, which is the base plate params dot thickness minus base plate params dot depth. Okay, so now we need to make sure that this is a construction geometry. It's not included in our sketch in any operation that we do. And now we need another construction line from here to here. This is also construction, and then this line and this line has to be perpendicular. Perpendicular, okay. And now this line is going to be our okay, sorry, I thought someone sent a message. Yeah, this line is going to be the tolerance. And now we're fully constrained. So let's hide the base plate just to see what's going on. So now we can select this sketch and cut everything through all. And now what we can do is, if I select this pocket, I can mirror it. And yeah, it's automatically selected the correct plane. But if it didn't work for you, you can select, for example, what is this plane? XZ plane. You can select the XZ plane and click OK. So now if I show the base plate and look at it from here, we're exactly 0.1 millimeters, which is our tolerance. So if I go back to the general and let's make this a 0.4 to make it really obvious, you can see it. Maybe we need to increase the depth a bit, so we can go to base pattern and make the depth like 6 mils. Yeah, now this should be a stronger part. And the reason I'm doing them this way is because when you print something on this face, for example, it's gonna be super strong. So if that's the plate, if I print it this way on the 3D printer, it's gonna be super strong in this direction. But if I print it this way, then it's not gonna be strong in this direction. It's gonna be strong on this direction. So we want it to be strong to support the lure. Now this this will not be as strong as this one, but it's still gonna be strong enough to hold it. Now what we can do is get this sketch and create a sub-object shape binder. So now we have this sketch in our moving platform, but it's right here at the moment, and we want to move it. We want to move it all the way up here. So how do we do that? In our position, we can just move it like this. Let's hide the base plate so you can see. That's our sketch. And now we can move it. Whoops. Yeah, so how much are we gonna move it by? It's gonna be, let's show the base plate again. So we know the length here, but there's some tolerance between the sketch and the base plate. So this is gonna be the general.tolerance plus the general.baseplate length, and this will put the sketch like right here at the end. And this is fine because we also need one here, but first let's do this one, which means we need to remove the thickness from the value. So minus general.thickness, and now we can pad this. The direction I think is reversed. Yeah, let's set it to 10 because I don't have a value for it. So let's go to motor holder, moving platform. We don't have a spreadsheet for this yet. Interesting. Should we use the motor holder param or no? Let's make one. So moving platform params, and let's call it the rail length. And we're gonna do it as it's 225. We'll change it later. Could have probably copied what we had in the motor holder params. If I copied this and I put it here, rail length input. So this is gonna have a minimum value of 15. And now we can come here and tell it this is the moving platform dot rail length. Now we can clone the sketch again and move it up here, but let's do something fun. The origin at the moment is right here on this line. So if I click the XZ plane and create a datum plane on it, I can move it in the Z axis, and let's put it exactly in the middle. So in the negative direction, minus general.thickness divided by 2. So now it's in the middle. Let's hide the origin. And also hide the datum plane, but remember its name, datum plane 01. Now click the pad and let's mirror it. And let's select a reference. Oh, we don't have it here. Okay, that's fine. Datum plane. Okay. So now we're gonna have a, I'm gonna have a problem. So this is convenient, so we can move it left and right, but I mean to make it more stable, but it's not printable at the moment. the only way to print this is to print it on this side, and you need supports for here. So no, I'm not gonna do that. Let's leave it with only one rail. I think it's gonna be enough. We can make it bigger. We can test it. If it's not stable, just increase it like that. Yeah. Okay. What else do we want to do? What do we want to do next? And we still want to somehow pin this in place. This is going to be moving, but this has to be pinned down. We can make some 3D printable screws or just pins and press them in place as a press fit. What else do we need? Let's see. So yeah, here I think what I did was, let me show you the files. This was what? This was this. Yeah. So this is the thing that gets in the previous design. It gets attached to this one. So this used to be one part, this and this, but the reason I didn't like it was, again, as I mentioned really regarding the print orientation, the only way to print this was to put it on this face right here. So if I can set it, this is how it would sit on a 3D printer, something like this, and this makes this part super weak. Yeah, and that's why I'm trying to make them as oh wait, yeah, it was 3 parts, my bad. So we had this part, which is this one at the top, and then we have this part below it, and then we have this third part. So this part and this part that has the logo, they screw together using normal steel screws, and this one just slides. So, or sorry, these two together, they slide on this one, and basically this this printed screw will just push against the other part to secure it in place. Now what I'm thinking for, we can either have the same mechanism, which is screw it down to tighten it. What would be cool though is if you can like stretch it, put your lure in the middle and then let it go, and there's some sort like of a spring or something that will get it back. We can probably achieve this using rubber bands, like 2 rubber bands, one on each side. This will work. I'm not sure if it will hold big lures. I think it should, but let's experiment with them. I can make one with rubber bands. If it didn't work, then I'll just delete them and add that screw. That's why I need to do these at the end. So this is gonna be at the end once I'm done with everything, like the cut for the motor. So I think let's start with the cut for the motor. Yeah, let's do that. So let's hide these two for now. Hide the moving platform and the base plate, and let's work on the motor. Where's the origin here? Let me just see. No, not here. Here. It's at the back. Okay, so we need to work at the back. And motor holder, I think I created, yeah, here. Sorry, just checking some notifications. Okay, so We need to define some stuff. Let's start with the motor diameter. And first, let me show you I think it was called TTY or something. TYT. TYT motor. No. Synchronous. Was it this? TYC. Asynchronous motor. I think that's the one. I'm not sure if it's the exact same model I had, but yeah, that's it basically. 220 volts or something. And I think it was 5 to 6 revolutions per minute. Do they have dimensions? Okay, cool. Cool. Diameter and thickness. We're not worried about the thickness. 50 shaft length, 20 weight. Okay. So for now, what was the diameter? 50. Let's put this to 50. We can change them later. Thickness 20. Now the tricky part is gonna be getting the location of these two, so we need to make them also a parameter somehow. But for now, let's say motor diameter input. We wanna know where is the motor, like how high is it? I'm thinking it's always at the top, but with an offset. Like for example, I want it to be at least 5 mil away from the top. So if we go back to motor holder params, come on FreeCAD. Let's say motor offset from top, and let's say it's 5. And these are inputs because we need to validate them. So what is the minimum diameter for the motor so we don't break the design? Is gonna be, we're gonna take the input and set a minimum diameter of 10. I don't think there is a 10 mil motor, but just in case someone enters 0. And the offset from top, we're also gonna give it a motor offset from top and a minimum value of 1. And now we can set the actual aliases. Is this song on repeat or what? Yeah. Why is it repeating? Okay, now it's showing the next song. I don't know what happened there. Okay, so we have the diameter and the offset. This should be very easy. So we go down here, create a sketch. What is this? Cancel. Oh, what? Oh my god, what happened? Nothing is pressed on my keyboard. What? Okay, my keyboard. Wait. Okay, something is wrong. Okay, now it's working. What happened? I have no idea what happened, but let's save just in case something crashed. So motor holder We need to make sure it's an active body. That was a mistake. Then we can create a sketch on the XC plane. I want to look at it from the back. So from the left. And I want to add a circle right in this center, right here. Constrain the diameter. It's going to be the motor holder params dot motor diameter, not the input, the diameter. And now I need to set the height. So this is gonna be a bit tricky. Not tricky, but requires some math, because we want this point at the top to be away from the top by a specific offset that we already defined. But now we're inserting the length of the center of the circle So this is gonna be general dot height. It's gonna be the total height up to the top. Now we're gonna remove the motor params dot offset from top. So now we're here. The center of the circle now is here, and now we need to remove the radius. So that's gonna be the motor holder params dot diameter divided by 2. And now we should be how much? 5 millimeters from the top. And now we can pocket it in the reverse direction, apparently through all. Cool. Now one thing, if I go back to that sketch, we need to somehow figure out the location of these 4 screw holes. And is there a better way? Is there a way to insert this motor without using screws? Probably there is. There is, because this has, if we have like 2 slits on the side, and then we insert the motor from the top, and then we can put pins in these holes to pin them in place. So it's gonna be a different design than what I did here. Basically, let's see if we can do it. Show me the pad just to see what's going on. Basically, what we're gonna do is start here from the circle, draw a line up. We need to make these 2 tangent. Was delete? Okay, you can delete other constraints, that's fine. And these 2 are also tangent. Good. And then we can draw a line here and trim this circle. So now we need to define this, which is our diameter or our radius. Motor holder to diameter divided by 2 plus the motor holder parameters dot the offset from top. Okay. And then we need 2 slits for these 2 to insert it from the top, something like this. But where do we put it? Like in the center, right here? I'm thinking about this. Hmm. This is probably like an outer circle here, or no? Is like an offset between this one and this one, or is it just like a straight line? The problem is that I don't have the motor yet. So I'm modeling based on pictures. I think we can just stick to the... Yeah, let's just stick to the to that basically. Okay, let's stick to this, and then we need to add some circles. Something like this. So let's go here and say screw hole diameter. Let's assume it's an M4 screw. And oh man, how are we? How are we gonna figure out where to place these? Because, okay, if we consider there's a bigger circle here, then we can put these on that circle, right? So we just need like an angle. We only need an angle. But is it? I think it is, yeah. Because the distance between here and here and the distance between here and here is like the same, kinda. No, it's not. This is farther away from the circle than this one. So it's more like we have a circle and then there's a line. Ah, come on. It's more like there's a line here somewhere. And they are like this. So how do we define this in parameters? Not sure. I'm not sure. If we consider we have one circle, I guess we can just define the offset. So we'll use only one of these or one on each side, of course, to pin the motor in place. Then that would be easier because we need two values, X and Y, relative to this, to the center. Or now we can consider this. Okay, but we also need two values, but anyways, it's like radial coordinates. So we need another diameter or an offset from this circle, which we can measure once we have the motor, and then the angle. But I think I'm gonna go with the X and Y. So motor screw hole offset X and screw hole offset Y. But the thing is, now the input validation for these are gonna be hard, because you want to make sure that this is outside this circle. And if you're relying on X and Y, then you need to calculate this line basically to make sure that it's always outside. And it's doable, but I would rather not have offset. Screw holder radius. What? What's this error? Angle or something. Recompute fail. Oh yeah, it's this. This has to be construction geometry. We cannot have it as a regular line, because the sketches has to be closed. So screw holder diameter, this is gonna be the input. And then here, let's validate the input. So it's the screw holder diameter input, and the minimum value is gonna be 1. Screw holder radius, no. Radius is not good. Distance. So how far away? Oh, come on. What did I click? Yeah, sorry. So the distance is gonna be this line basically. What's happening? Yeah, it's gonna be this line. And let's say this is... So this is why we're using distance, because now we can do something like this. It's gonna be the minimum value 4. The screw hole, I forgot to add an alias here. Input. Okay, now is going to be equal to screw hole distance input, and the minimum value relies on the motor diameter, which is motor diameter, not just motor diameter, but motor diameter divided by 2, which is the radius, plus the screw hole diameter. Let's leave this at here now, and I'll tell you why, because we need to add an alias here. We need this value, screw holder diameter. Okay, so we have the radius, and we need to add to it the screw holder diameter, and now we're like dead on the center. So let me show you, but we don't want that, so we're gonna change it in a bit. Screw holder distance is gonna be this distance. So if I come here now and take this and I tell it that this is the motor holder param dot screw holder distance, and then this has a diameter of motor holder params dot screw hole diameter. Oh no, wait, what? Oh, we need the radius only. Sorry, my bad. So this is also divided by 2. And we need to reload the sketch. Okay, that's interesting. They should be touching. Anyways, I think they are touching, but it's like a rendering thing because it renders. By the way, we can fix this. You see, it doesn't show it as a smooth surface or as a smooth circle. And we can fix that in the view deviation. We can lower this number, like set it to 0.1, for example. And then if I open it again, okay, that's weird. Should theoretically change. Or will it only work for solid bodies? Let's do 0, 1. No? You cannot go below that? Or is it because it's open? No, it's not open. Anyways. Now it's directly on it. And we want to add at least, in the minimum value, at least 1 mil between them. So now it gets it to 28, but let's set it to 30. So we have more, we have more in between them. Now I want to set the angle, which is here, screw holder angle. Let's set it to a random value for now. Screw hole angle, input, and the value is gonna be screw hole angle input. I mean, do we need the minimum value for angles? I think angles are fine, right? Angles could be anything, like 0. Maybe it shouldn't be 0. Let's see. I want to test this. So first of all, the angle from where? Let's do it like that. And then this is a construction geometry. Let's do it like this. So if I take this from here to here, can I set a value of 0? Yeah. Now I can go to the angle and I can set it to -5, right? Yeah, it works. Like 2000. Okay, so the angle does not need any constraints. Cancel, go here, model param, so no need for the input. Just screw hole angle. But 45 is too much. I think it's more like 25 or something. More like this. And now we can mirror it. To active body to be on your document. What? Oh, wait. Can we mirror it? Because it's 2 circles, not 1. But in order to use part design, you need an active body, but it is active. What? It wasn't? That's stupid. Yeah, we can mirror it. Vertical sketch. Okay, so the motor is done. I think that's it for today. This is definitely gonna be a 2-part. We still have lots to do, so let's go over what's left to do. We need to secure this part into this part somehow. Again, I'm still not sure how. Probably some screws or like a pin that will pin it in place. Then we need to model the, what was it called? This part right here. So we need to model this opening. We need to model something that will accept ball bearings, that will rotate. And probably I think I'm gonna remodel these threads, that we can thread some attachment to them, and we can do multiple accessories. Like for example, someone suggested we can do a magnet bar. So it's gonna be like one long magnet bar, and then you can like super glue a couple of magnets to it, and some people use that to like rotate their lures. But yeah. Oh yeah, we need a way to either attach this or secure it into the plate, or as I said, a spring mechanism, that where you like spring it open, put your lure, and then let it go, and it will secure it in place. That would be super cool. Yeah. But yeah, that's all for today. We will continue this next Monday. And by the way, I'm streaming almost every day on Twitch if you want to join. But it's more of a me doing some programming, and I'm learning a game engine. Probably in the future we'll make a fishing game. So yeah, just search Lure Logic on Twitch or join my Discord server. I send all the links on Discord. And I forgot to upload. Not forgot, actually, to be honest. I didn't have enough time to upload the tackle box that we made in the previous episodes, and that's because I usually don't upload anything to Printable before I test it myself and make sure that it works, because I used to randomly upload stuff that I make before I test them, and then I go test them and they don't work. So I don't want you guys to like waste filament on something that doesn't even work. So let me just give me some time to test it, make sure it works, and then I will upload it. The same for this one. When it's done, I'm gonna order the motor and the ball bearings and probably some magnets, and we'll see about the springing mechanism. I think just regular oh my god, what they're called? Frame freeze. Rubber bands. Regular rubber bands will do just fine. We can have two, one here and one here. The same on this side. We attach them. Oh, we have one more thing. If we wanna stack base plates, so I want to print like 4 or 5 base plates and stack them next to each other, we need a way to attach them. We will think about this next Monday. Shouldn't be super hard. But yeah, that's all for today. If you have any questions or anything, send them now in the chat, or send them on Discord, or add a comment to this video once it's uploaded. And have a nice day. I'll wait for a couple of seconds just to see if you guys are gonna send anything. Oh, these music are nice. these songs. I usually go to like music and then set a mood like uplifting or something. But now I tried TikTok soundtracks. Okay, I guess there are no questions. So have a nice have a nice day, and see you guys next month.